Hi, my name is Chen Kang and I'm from Group 6, Section 15. So today I will be introducing our circuit for AC to DC power supply. So in this circuit, we can see that we use a transformer and a bridge rectifier and a capacitor and lastly a zener diode. So for our value for our input voltage will be sine 0, 240 and 50. 240 stands for 240 volts and 50 stands for 50 hertz. Now this is our transformer. As you can see, our labeling K, L1, L2 and 1. So this shows that K equals to 1. You can see the value of L1 is greater than L2, so it proves that this is a step down transformer. Now we can run the stimulation. In this stimulation, we can see that the voltage at the primary coil is almost 240 volts, but the voltage at the secondary coil is approximately half of the voltage at the primary coil. So this shows that our ratio for this transformer is 2:1 ratio. Okay, now I will be explaining our bridge rectifier. You can see that our bridge rectifier is made up of 4 diodes. That is diode 1, diode 2, diode 3 and diode 4. So the bridge rectifier allows diodes works in pairs during alternating half cycle of the voltage input. So you can see that the diode 1 and diode 2 are working in pairs, while diode 3 and diode 4 are working in pairs. Okay, now I will run the stimulation and prove why we use 4 diodes in this circuit. So if we only use 2 diodes, that is diode 1 and diode 2, we can see that the voltage produced is very unstable and it forms a very large ripple, so it's not smooth. But with diode 3 and diode 4, the voltage will be much more smoother. So this is why we use 4 diodes in a bridge rectifier. Okay, after the bridge rectifier, we will add a capacitor in the circuit. So as we know, capacitor acts as a filter in the circuit, and we also acknowledge that capacitor charges very fast, but it charges at a very slow speed. So it will help to produce a smoother DC voltage. We can see in this simulation, if we only have the bridge rectifier, the voltage produced is not very smooth, but with the capacitor, you can see by looking at the red line, the DC voltage produced is much more smoother. In order to eliminate the ripples, voltage regulator is added to produce a smoother DC voltage. A zener diode, you can see here, is placed, will act as a regulator in the circuit. The zener diode will be placed in reverse bias, which will be connected parallel with the output loop. So by running the stimulation, you can see after voltage passing through the zener diode, the voltage is very smooth and it is a constant voltage. So in conclusion, we can summarize this circuit. We have a step-down transformer, and we have a bridge rectifier made of 4 diodes, and we have a capacitor that acts as a filter. Lastly, we have a zener diode that is the voltage regulator. So this will be my presentation for this circuit. Thank you very much.